Okay. Okay, great. It looks like Hannah was planning to join, but not here yet. So regardless, we'll start. Um, nice. So first, welcome to this course. Um, welcome to students who are joining online to the live stream, as well as welcome students who will be watching this recording. So this course, first want to give everybody an overview. In this course, we're going to talk about the essential principles that applies to software development, or sometimes called software engineering. Basically, the goal is to apply the best practice that was considered good within the industry to help deliver quality software as fast as possible. And then to break it down, we'll have many modules. We'll talk about programming language, we'll talk about framework, architecture, tests, DevOps. Basically, we'll touch many aspects of software development, as well as actually operating a software or operating a service. And then the scope is actually pretty big, so the schedule is pretty tense. We are trying to squeeze everything into this 1 quarter course where we need to touch many topics. So some of those we will just skip, and then others we will just briefly touch on that. So later I will give a more detailed overview about this course, but before we get to that, I want to go through some basic informations. So these are the information I've already uploaded to Populi. So here, for example, you can find our Telegram chat. Some of you is already in the chat, but for some of you that hasn't joined the chat yet, you can find the link here and then join the chat. Most of the announcements, updates, I'll post it there. But it's okay if you don't want to join. I will also email you the same announcement. Next, which is very important, is regarding the grading policy. I think everybody is concerned about their grades, so I want to first talk about that. For me, the policy is pretty simple and straightforward, and I usually just go exactly or strictly according to the policy. So basically, to get a pass or receive an A, what you need to do is simply show me that you've put in the effort by attending the lectures on time, and then for online students, by watching the videos, and then you will be required, for online students only, you'll be required to leave a comment or just say something so that I can see that you've watched the video. All right. And then by finishing all the required assignments and homeworks, and then from a certain perspective, it's actually easy to pass my class, because even if you got it wrong, it's okay for me, because all I need to see is you put the effort to get the pass. So as long as you submit your homework, attend the lectures, and then finish the final exam. We will talk about the final exam later. And even if you do horribly in the final exam, as long as I see your effort, I will give you a pass. So from that perspective, it's easy to pass my class. But I'm also very strict So if you don't submit any homework, or don't show your attendance, and I don't see your effort, even if you do great in your final exam, I will give you an F. All right, hopefully that's clear. And then to get better grade, what I want to see is you show good deliverables in terms of your homeworks, right? You get all the answers correct, and then maybe do some of the bonus assignments. So in this course, I will give required assignments and then bonus assignments, or actually I should put it this way. I'll give basic assignments and bonus assignments. The basic ones are in general simpler and don't require too many hands-on programming tasks, because I understand some of you are freshmen and this is probably your first year in school, and this might be your first course. So it's okay that if you feel difficult to complete all those coding assignments, I totally understand. So I will give you an option to go with a basic assignment option, which basically you don't need to do much coding, and then you will still get a chance to pass this class and even get a B. Okay, and then in order to get an A, what you want to do is I want you to try to finish all the bonus assignments, basically the hands-on coding assignments, as well as a final project. Okay, so hopefully that's clear regarding the grading policy. Just want to emphasize again, to pass this course, I want to see your effort. Even if you get answers wrong, as long as I see your effort, you get a pass. Otherwise, you will fail. All right, so make sure to submit your homework. Okay, so that's the most important thing. We've talked about that. Then we're going to go through some of the course materials. First, if you go to Syllabus, there's a simple description about this course. We'll talk about the assignments breakdown later. This is Syllabus. You can see the outline of every week, the topics we're going to cover. And then here's, most importantly, the link to edX online courses. There are actually in total 3 courses offered by Berkeley professors. So that's what we're going to use for this course. Most of the videos and materials come from that. So if you click the link, you will actually see this edX page. So the first course is Introduction to Agile Software Development Tools and Techniques. And the second course is Advanced, and then the third one is Mastering. It's funny that they name it that way, because actually all these 3 courses are one course. I don't know why they break it down into 3 courses. It's all intertwined, and basically the way you should be watching or taking these courses is taking the first one, which is Introduction, and then the Advanced, and then Master. And you will see that, where's the modules? Let me actually logging. So each of these edX course, it has 4 modules, which almost matches the syllabus here. And then basically each week we're going to finish 1 module. However, the first 2 weeks are going to be very intense, because we have limited time. I had to squeeze module 1 to 3 into 2 weeks. But also on the other side, these are very basic, learning a new programming language. It actually, for you to be a good programmer, you got to learn this skill. Like, you never know which kind of language or programming language you will run into. There might be a specific tool you want to use, but in order to use that tool, it requires learning a new language. For example, a few years ago, Google released a mobile app development tool, which is Flutter, and that one uses a language which is not that popular, I would say, and that is Dart. So in this case, like, if you want to use that new fancy development tool, you will have to learn a new language. But that should be something really common for a good programmer to learn. And the other case would be, like, you will be handed over a project that someone else built. You will be tasked to maintain it or add new features and modify it. And then you don't know, it can be written in PHP, Python. You never know what we will get. So basically, what I want to say is, even though it's like a separate module in edX, I'll try to spend less time talking about learning a new language, or in this case specifically Ruby. So hopefully you already get some fundamental programming skills. Like, maybe you've already learned a programming language, something like Python, PHP. Otherwise, like, for you to learn a new language in a week is basically not possible without any fundamental skills. So if that's the case for you, I would say don't worry about that. Just go with the basic assignments options, because even though we have many optional coding practice in this course, it's also totally fine to go with basic assignment options, which don't require many codings. Because the goal for this course is to, learn the principles of software development instead of really develop a software. So, for example, if your career goal is to be a product manager, project manager, a team lead, by learning these principles, you can still have a good understanding of how a software is developed and how to better manage it and how to work with the team to develop it without yourself going hands-on. Hopefully that makes sense. Okay, going back. So that's where we get the course materials, these 3 edX Berkeley online courses. And then if you're interested in some of the videos and materials I would skip, feel free to also register. It's free to sign up and then get into the course, and you will have access to all the course materials. And then the other thing I should mention, every module it includes a quiz, but we will skip all the quiz here. The assignment will be independent from the quizzes here. So feel free to enroll these edX courses, but also it's optional. If you don't want to, you don't have to. Okay. And then textbook. So here are the books. The required book is the textbook. which is engineering software as a service and agile approach using cloud computing. It's basically a one-to-one match to the online course. So if you click that link, oh, it doesn't link to it. Okay. Okay, it just you will just see the basic information, the title, author, and then ISBN. But I do have a link here. So under links, you'll find a textbook free PDF download, where it actually leads you to the homepage of this book, and you can find this link over here, free PDF download, and then you can just click it, download, and you will get the PDF file. It's a 400 pages book. So in order to do the basic assignment options, what you will need to do is just read through this book, basically write a summary for the corresponding chapter, and that will be the basic option for assignments. And then the bonus option is to do coding practices. So later we will get back to this book. And then the other two books. So first is Mythical Memoirs, which is a classic for software engineers. If you plan to become a software engineer, this is almost a must-read book. It talks about, it's actually a pretty old book. It was first published like 16, 17 years ago. But many of the issues, the stuff the author addresses, and then the problems that the author brought up also still apply to the software engineering today. So it's still a really good reference, and you can probably connect once you really get into the industry or get into some ministry work. You will see like some of the things that the book talk about is so true, and then it also actually give you a different perspective and sometimes give you a solution or some advice on how to tackle certain situations. So this is a really insightful book. And the other one is Effective Project Management. This one is more recent. The latest edition was published 2 years ago. It basically gave a really organized and then broken down perspective about project management, or it actually doesn't specify it's for IT or software projects, but you can easily apply it to software projects. And then it touches on different steps in the procedure and look at different problems and address different issues. So these two books, Mythical Memoirs and Effective Project Management, these two books are recommended books. It's not required though, so if you don't get the time, it's okay that you don't read it, but still I highly recommend it. And if you, for example, want to get into a project management role, or get into some sort of leadership in the tech world, and then definitely these two books are something you should read, and I will highly recommend it. Okay, and then I will later send the PDF copies of these two books into the chat. But the copies I have is not the latest editions, so if you want to buy the latest one, feel free to do so as well. Okay, so that's about the books, and then additional courseware for hands-on projects. Um, in the course syllabus, you can also find this link, which says courseware and hands-on project source code repo. And this is a GitHub repo. It's basically the source code or unfinished source code for most of the coding practices we will be doing for the bonus assignments in this course. So if you choose to do these assignments, then you basically go to the corresponding repo, clone it. Oh, where's the clone button? Oh, fork it. Then fork the original one, and then solve whatever it asks you to solve in order to do the practice, and then commit it and push it back to GitHub. And what you will submit it in Popular is to basically submit your GitHub repo, which is a fork of this repo with your own modification. Okay, so hopefully that's clear. That's where you find all these resources, books, links, everything is here. All right, then let's talk about grading a bit more. So I already touched on the grading policies, and then this is how we break down the scores. 20% will be your attendance and participation, basically by joining this live stream or by leaving comments in the recording. You'll get 20%. And the homework, which is basically for the basic assignment option, you can just write a summary of each chapter. And that goes for 40% of your score. But I want to mention though, so because it's a basic option, maximum you will just get B by doing that option. Whereas the bonus option is to do the coding practices, which will require you to actually program and write code and do all the hands-on stuff. But if you do that, you will be able to get an A if you do all these correctly. Regardless, the homework accounts for 40% of your score, and then lastly, a final project or final exam will account for another 40%. So again, I will give you guys options here. You could take final exam, which is kind of the basic option. I will just run through some questions, and then you will answer it for a document, and then submit it, and I will grade it based on that. The bonus option is, of course, a final project, and then I will talk about the final project a bit here. So basically, you can already start the final project once you finish this today's lecture. What I will ask you to do is apply everything you learn from this course to one of the projects you're working on. It could be something, some project you do in your work, in your ministry. It could be something you do like for a personal project. It could be your side projects. Any project is fine, as long as developing a software. And then you apply everything you've learned in this course to the project you work on. And then give a demonstration to show, like, so you did this practice. For example, later we'll talk about like test-driven development. Oh, you add some of the testings to certain component of your project. Something like that will be enough. So that will be the final project. Again, you have the chance to choose. You can go either with the final exam, where I just give you questions that doesn't require you to do any coding, or the final project that you actually apply the knowledge to one of the projects you work on. Okay, so that's about the assignments and how we break down the scores. Okay, finally, let's get started. Oh, actually, before I continue, any questions? So YouTube has the comment function. You could also leave a question. If you have a question, you have something to bring up, feel free to send a message in a comment or chat, whatever YouTube calls it. It should be like, if the video is here, it should be something down here. Okay, so I don't see any message in the chat, so I guess no question here. I'll just move on then. So now let's get into the real thing. Let's look at the syllabus first. So we'll have these modules. Basically, each week we will cover one module. The things we'll cover first, actually I should say, so even though this course is about principles, we still actually have to use examples to demonstrate the ideas behind these principles. So we will still have to go through some of these examples that actually develops the software. And in this course, we will use Ruby as a programming language, and then Rails as the framework. And then we will talk about JavaScript for front-end or browser front-end. If you are not familiar with these ideas, like web development, web framework, front-end JavaScript, I would suggest to register the other course I think that's also being offered this quarter, which is the web development course. And if you're already registered to that course, then good too. Simply because we don't have enough time to go through all the things that matters for web development. So if you don't have that skill, it's better for you to just take that course. But still, because we have to have an example in this course, we will use web development as an example. Even though software development actually covers many other kind of projects, not just web. A few examples like mobile app, like a crawler, like a desktop application, like a IoT device application. So there are actually many kinds of softwares that actually we can also apply the principles that we learn in this course to those projects. But again, we need to have an examples, and then since web is just kind of simplest one, and kind of a best example for our course. And then again, nowadays many softwares are developed and delivered in the form of web application. So that will be our choice for the course. Okay. Oh, and then I should also mention about Ruby. Again, if you don't have any experience in programming or using a programming language, I would suggest you to take a programming language course, or on Courseware. Let's see. There's a Python course. Python for everyone. So that's good. This course I've briefly went through it, and I would consider it a recommended course for anyone just new to programming world. If you want to pick up a first programming language, I would recommend Python, and then this course is good for beginners. So, but since we don't have the time to actually, learn to going through all the details and learn new language, and then we can just dedicate pretty much half week or just one lecture basically to go through Ruby. If you don't have experience with learning a new programming language, or don't have experience with programming itself at all, I would recommend you to take another course for that. Okay, and then once we cover these, we will talk about behavior-driven development. We'll talk about tests. We'll talk about legacy code, which you will for sure deal with somewhere in your career if you become a programmer. And then, actually, we'll talk about details later. And then we will talk about Agile, which is a group of practices that nowadays many development teams do. We'll explore that idea that week, and then we'll talk about some design patterns. Again, if you don't have experience with programming already, it will be hard to catch the idea about design patterns. So if again you're a beginner, take the programming language course first, then find a good book. I have books to recommend that talks about design patterns. If you want to learn more about that, feel free to reach out to me, and I can send you a copy of that book. But otherwise, we just have 1 week to talk about design patterns, and probably we can just cover the surface for that week. And then week 10, we'll talk about DevOps, which also is a very common practice nowadays, where compared to what it used to be like 5 years ago. We'll explore what that is and the benefits from it. And I actually offered another course a few years ago about DevOps. It should be still sitting in my YouTube channel. So I could, if anybody is interested to learn more details about DevOps, feel free to reach out to me, and then I could probably find the videos and send you a link. And then last week, we will do a quick recap to go through again what we've talked about, and then we'll have the final exam, or if any of you choose to do the final project, that will be the time for your presentation for the final project. Okay. Okay, now let's get into the content. So for this week, we will basically go through these videos from Module 1 of this edX course. I kind of go through the syllabus I just talked about, but in a more detailed way. So it touches on every single topic, and then explain what that is, some of the details, and then the main goal of these practices. Without further ado, I will now play the videos. And then let me know if you have trouble streaming these videos, because I'm using the software to broadcast the video. I tested it should be okay, but yeah, again, if you run into any issue watching the video, feel free to stop me and send me a message.
Hi, I'm Armando Fox, and I am really excited to guide you on this journey into engineering software as a service. Back when I worked at Intel, a colleague and I were working really hard to understand how a complex piece of software worked. And I remember him saying, "Don't worry, it's not magic, it's just software." But the thing is, software is almost like magic. We think about what we want the computer to do, and then we can make it do those things. And in the last 2 decades, cloud computing, software as a service, service-oriented architecture, and the explosion of mobile apps have transformed the way that we write software. The tools are better than ever, and the opportunity for a small team of developers to have a major impact on millions of people is greater than it's ever been. That's why Turing Award winner David Patterson and I developed this course in 2012 to bring modern, agile software engineering techniques to Berkeley students. So, who is this course for? Maybe you're here to learn to code. In that case, this may not be the best course for you. We expect that you'll have experience in one modern object-oriented language, such as Java or Python, and that terms such as encapsulation and inheritance, functional programming, or phrases such as class versus instance variables, interface versus implementation should sound familiar to you. We don't expect you to have any experience with HTML, web programming, or databases, though if you do, you may be able to skip a few of the recommended review assignments. Because software engineering is more than coding, it's working with a team, producing code that's not only correct and useful, but beautiful and maintainable by others. So in this course, you'll learn how to use the same tools and techniques the professionals use to create software as a service, the most widely deployed kind of software today. Or maybe you're here to learn a particular framework, like Rails for writing cloud apps or Android for writing mobile apps. Although we will use some frameworks, the world of software moves really quickly, and the most valuable software engineers are those who can learn new languages and frameworks and evaluate which ones are the best choice for a given task. So, while we won't focus on any particular framework in depth, you will learn how to approach new languages and frameworks so you can become productive in them quickly. If you're here to learn to pick up new languages and frameworks quickly by looking at the big picture and leveraging what you know from other languages, if you're here to learn how to work as part of a team to start adding value quickly, whether you're contributing to a large existing software project or starting a new one from scratch, if you're here to learn how to write code that, because it is clear and maintainable, will enjoy a long, useful life solving real problems for real customers, and if you want to learn how to do all of this using the same cloud computing facilities, tools, and techniques that professionals use, then you're definitely in the right place. And we look forward to helping you develop the skills for software engineering, the profession that can change the world. Thank you for joining us, and good luck in the course.
Alright, that's the first video. And we'll watch the next one.
Hello, and welcome to Engineering Software as a Service. In these short intro videos for each module, I'll not only tell you what you can expect to learn in the module, but also try to give you the big picture of what to keep in mind as you're learning it. For this module, the big picture question is, why is it that we can build complex machines like airplanes and suspension bridges that have great safety records, yet virtually all software ever written seems to contain bugs? sometimes really severe bugs that result in the loss of data or allow a successful attack by malicious adversaries. The term software engineering was coined in 1968 by MIT scientist Dr. Margaret Hamilton, the leader of the programming team for the navigation computer on the Apollo spacecraft that put the first humans on the moon. Software engineering was supposed to make software as reliable and as predictable to build as civil engineering had done for suspension bridges or aeronautical engineering had done for airplanes. But software differs from hardware in a very important way. In the plan and document processes that software engineering originally tried to adapt from civil and mechanical engineering, change is considered the enemy because hardware can't easily be changed once it's built. It's really hard to add a row of seats to an airplane or an extra lane of traffic to a bridge after they're already in use. In fact, in California in 2003, they did add extra lanes to the 40-year-old San Mateo Bridge, and it cost just as much as building the bridge in the first place. In contrast, software can continue to add features and adapt to customers' needs long after it is first deployed. This remarkable ability to change means software can have a potentially long service life. In fact, the U.S. Defense Department's contract management software might be the oldest software still in use for more than 80 years. But change also means that software is potentially always trying new things and learning from mistakes, as it tries to keep up with customers' evolving needs. Indeed, early suspension bridges and airplanes did fail because the designers were trying new techniques, and once they learned from their mistakes, those machines did become much more reliable. The malleability of software is the reason that in the early 2000s, a group of software engineers proposed a new way to develop software called Agile Development. Instead of considering change to be the enemy, Agile embraces the fact that software can change after it's in service, and instead asks the question, how would we redesign software development processes to take advantage of that flexibility while managing the software's complexity so that changing it later isn't a nightmare? In this module, you'll learn the differences between plan and document and agile approaches to software engineering. You'll understand how to choose the right approach for a particular project and get introduced to some of the processes and tools that Agile uses to accomplish its goals. Don't be surprised if some of those processes and tools are new to you, such as writing tests before you write code, or hoping that someday someone will refer to your software as legacy code. Our message, and the message of many students who have taken this course, is this: trust the process, embrace the opportunity to learn something new, and we believe it will dramatically improve the way you create your own software.
All right, so that's the second video. Basically, the professor there brought up this idea of Agile and then some of the reasons behind it. Before we get into the next video, I do want us to start thinking about that. So the other thing I want everyone to do in this course is exercise your critical thinking skills, right? Even though the professor in this course talk about many good practices and then largely adopted by the industry, but still, depending on the projects, depending on the resource you have, depending on the timelines, depending on your specific situation, some of these practices may not make sense, right? Or it's the whole the agile thing, even though you don't know what is agile yet, but just by watching this previous video, the professor actually already mentioned the agile practice was brought up to adopt changes in softwares, but there can be plenty of scenarios where agile Agile don't make sense in some software projects, right? Basically, so again, in the video, it's mentioned Agile was introduced to better accommodate changes in softwares, but there can be cases where it doesn't fit. Like one of the example, actually I will pause for a moment and let all of you to think about that a bit. Is there any scenario where that there's no change involved, or there will be no changes that's like relevant in some kind of project? And actually, feel free to leave your comment in the chat. Let me see if I can see the chat. Yeah, if you have any idea, feel free to comment in the chat. But for this one, I'll just go ahead. Like one of the examples, it actually happens in many like freelancing or outsourced projects where the freelancer or the outsourcing partner, they actually don't care about changes. Actually, whether you are the client or you are the freelancer, it doesn't matter. There are cases where a project was requested and then developed and then done and delivered back to the client, and chances are it will never get changed again. Or you won't care about the future changes because there's a good chance the client would find someone else to do the changes. So in those cases, like you don't necessarily need to go with the Agile approach. Even before we talk about what is Agile, it's fine. Like because the reason for Agile is to better adopt the changes. But if you don't care about the future changes, then why bother doing all that? So that's just an example. And let's get into the next video.
Thanks everybody for being here. I'm Armando Fox, but you probably already knew that. And the pattern of the semester is usually such that you are never going to be more excited about this class than you are right now, because it's the first day of the semester. So my goal is not to lose you. I will do everything I can to make this a really fun experience. Yes, go join your friends, it's all good. I will do everything I can to make this a really fun experience. And I was going to start out with something that I'm going to bring back every lecture or two called Armando's Computer History Minute. And I do want this class to be as interactive as it can be, given that we have a lecture format. Does anybody recognize the woman in the picture? Sir? Margaret Hamilton. Did anybody else get Margaret Hamilton? And if so, would somebody else care to explain what is noteworthy about Dr. Hamilton in the field of software engineering? Anybody? Bueller? That reference doesn't work anymore. Do you want to elaborate, or shall I take it? The Apollo guidance system. Thank you very much. So let us watch a short YouTube clip to get the ball rolling. And what you're listening for is alarm. Let's see if this works. Why? Hold on. Let me move this. There we go. All right. Now it'll work. Everybody hear that little clip? 1201 alarm. I assume everybody knows what's going on in this clip. This is the first time that human beings ever landed on the moon. And the guidance computer in the Apollo spacecraft was indicating an alarm that it had basically run out of processing power. What had happened was that one of the astronauts had left one of the external antenna dishes pointed in the wrong direction. So as they were trying to maneuver down to their final landing, the antenna was essentially picking up garbage. The guidance computer was trying to parse the garbage. It didn't have enough cycles to both do that and monitor the real-time landing maneuvers that Neil Armstrong was trying to do. So it raised an alarm saying, I'm going to discard the lower priority task of parsing garbage so that I can concentrate on the higher priority task of not crashing into the surface of the friggin' moon. And the innovation that Margaret Hamilton came up with, which allowed that to happen, was the idea of dynamic priorities. Until that time, computers that were doing different processes simultaneously, multiprocessing, were essentially round-robining with static priorities among them. And she came up with basically the insight that in a real-time system where an emergency might arise that really required the computer to divert resources to a critical task required a different kind of scheduling mechanism. So besides that, she's credited for having invented the term software engineering. Software was the thing that made NASA realize that actually building hardware, as difficult as it is, was not going to be the bottleneck pacing item in future space missions. It was going to be the software. So we have Margaret Hamilton to thank for an innovation that really is fundamental to real-time operating systems now, the concept of dynamic priority scheduling. There's a photo. By the way, if you're interested in this sort of thing, I'm kind of a computer history geek. A NASA intern a couple of years ago started uploading all of the Apollo 11 computer source code to GitHub, so you can go check it out. It's in the public domain because you as taxpayers paid for it, or probably your parents paid for it. This is Margaret Hamilton as part of the MIT team that was in charge of doing all of the Apollo 8 software. She was one of the development leads, everyone clad in 1965 attire and probably watching carefully to make sure that their software is actually working all the way down. So I think that's kind of an intro to the first question that I have for you all, which is, you've all written code, at least I hope so, or it's going to be a sad, sad semester for you. But what is software engineering beyond doing that? What's the difference between what you are already doing or programming and software engineering? There's no right answers, but there are many, many wrong answers. I'm kidding. Go ahead.
The art of building things in a sustainable manner.
Building things in a sustainable manner. That's good. And maybe more specifically, building things that people who come long after you've left the project, might be in a position to take over. Anybody else? Distinction between what you do when you are sitting at home working on a hobby project or a course assignment versus software engineering. Another critical distinction. Here's a hint. Anybody? Sir? Probably working in groups, right? We are way past the point where sort of the lone genius shutting themselves up in a room with Red Bull is going to produce the next software breakthrough. Most interesting software that you want people to actually rely on is way too complicated for that. So working effectively as part of a team to do that is one of the most important things in this class. David Parnas, a very distinguished software engineer who's written a lot about software safety and how teams work together, has said that the main thing that distinguishes software engineering from programming is that it's multi-person development, so teams, of multi-version programs, programs that evolve over time, as opposed to you build it, you put it out there, and you're done. Anybody recognize this Turing Award winner? He's on the caption. But in case you don't recognize him, Fred Brooks led the development of the operating system software for the IBM 360, one of the machines that is really regarded as having changed the game for how we think about computer architecture, the programmer's view of a computer. The lessons that he learned from that in the book The Mythical Man Month should be required reading, I think, for everybody doing software. But he says part of it is combining separately written programs and making them suitable for use by the people who had not written them. I'm going to take suitable for use to also mean suitable for continued development. So before, we had someone here say doing things in a sustainable way. One aspect of sustainability is long life. And he rightly pointed out that even today, these topics don't receive maybe as much attention as they should in programming courses, hence software engineering courses. If you talk to people who do software engineering now and you ask them, who are your best software engineers and what makes them great? There was a survey done about 3 years ago at Microsoft, and kind of the high order bits that came out of that is that there's 4 clusters of qualities. There's personal characteristics. Good software engineers are passionate about what they do. It's not sort of just a job for them. They're data-driven, and they're improvement-oriented and open-minded. So they're open to the possibility that there's a better way to do something than the way that they've been doing them. They're also the kind of people you want to have on a team. They're there to help their teammates. They want to create an environment where making mistakes is okay, where putting crazy ideas forward is okay. Sometimes they call that a safe haven, or feeling like the team has a psychologically safe environment. We're going to try to get all of you to sort of get into that space, right? Everybody in this room is able to be a great contributing member of a software engineering team, and there are specific things you can do to make yourself the kind of person that others want to hire and want to work with. There's a cluster of technical skills. You have to know what you're doing. And part of that is coming up with creative thinking. Part of it is thinking ahead to what technical needs might we encounter, and is there something in my past experience that I can bring to this project to help solve those problems a little more elegantly. Most of these problems are not about learning new technology stacks, right? Nobody really cares which technology stacks you know. It's how quickly can you learn a new thing, come up to speed, and start contributing in a way where you can bring new ideas into a project from day one. And finally, when it comes time to make decisions, especially technical decisions, knowing who your organization is, not just your team and your company, but your customer. How does your customer work? What are the different levels of the situation? The customer has some needs, there are technical constraints, sort of balancing some, what I'll call socio and technical aspects. So software engineering really is about all these things. And lest this feel like it's sort of way too touchy-feely and not enough about coding, there's a lot of great technical stuff in this class. But if you don't know how to bring those technical skills to bear with other people working on a team to produce an artifact, then software engineering is probably not going to seem like a lot of fun. So having said that, I hope that most people here are excited about doing that, because that is our goal. We want you to learn how to do software engineering in a disciplined way, in a way that's customer focused, which is putting what the customer thinks is important first, not something you think the customer would think would be cool to have. We will use, by and large, Agile development methodologies, not because they are the best, but because, as you'll see, the kind of projects we're doing, software as a service, turn out to be a very good fit for Agile methodologies. So today is going to be kind of a whirlwind overview of what we're doing in the course, expectation setting, what you all should expect from the course, what I expect, what your predecessors, students who have taken this course before, what things they have found to be challenging, and we'll see how far we get.
All right, that's the third video. So I do want to mention a few things as well. First, Professor talked about software engineering. So I do want us to think about what is not software engineering. Again, I'll pause for a moment. Okay, so one of the thing that has mentioned is it's a teamwork. Involve designing. Yeah, that's also great. Yeah. So I do want to say, like, for example, the way the professor talked about software engineering. It's based on teamwork, right? But in real world, there are cases where you are just one-man shop, where you are the only programmer or only developer that builds a website. So in this case, like, some of the practices in Agile doesn't really matter that much. And then one thing that one big idea that I think is very interesting from the Mythical Mammoths book, it talks about the reason behind software engineering was that basically at the beginning everyone is basically one-man shop and then build the software by one person, but down the line at some point, like when people start to build something complicated like a operating system, right? Then it gets difficult for one person to develop it and maintain it. And the other main reason is that there will be time constraints, right? For a company like Microsoft or Apple, it doesn't make sense for them to build a operating system like which will take, let's say, 5 years. They need to get it done like in a year or two. Then, in order to fit into the timeline, it kind of became the only choice where the companies need to have multiple engineers working on the same project. Like when we talk about software engineering, many of the things that actually become important when there's teamwork going on, and also the other thing mentioned, Mythical Mammoth's book, it talk about efficiency or productivity. It basically says the more people gets involved in a project, the productivity gets lower. So ideally, for best efficiency, like all the projects will just be worked on by one single person, because that means there's no communication overhead. And as a result, you know all the ins and outs of the program and the software. So because of that, the design of the software is coherent, and there will be less bugs, and and then because you already know certain things, when you need to make a change, it's also faster. So, like because of time constraints in the real world projects, we cannot avoid have teamworks. Whenever we have a tight time constraint or a software becomes too complicated, then we need to introduce all these practices from software engineering world. But otherwise, actually, like let's say you work on a one-person project, then you can actually think about which practice is necessary and which are not, and then pick and choose depending on your situation. So again, just want to revisit what I mentioned already. Throughout this course, I want all of you to exercise critical thinking. Even though all the things we teach us here are good practices, but still, depending on your situation, some of the practice may not fit your project. So don't be afraid to actually question some of the choices or advices we make here. And again, if you have any question, feel free to reach out to me, and we can definitely have a discussion over these topics. And then another example, like the last frame, if I could go back.
Our technical, I expect what your predecessors, students who have taken this course before,
Okay. So even though this course we will talk a lot about Agile, but still Agile, like here the professor already mentioned, it's a good fit for software as a service, right? Which is actually a specific type of software project. Other examples that I've already talked about, like IoT devices, even something like mobile app, where you cannot simply just release and release a new version, deliver a new version, and iterate that fast. So, in those cases, again, you need to pick and choose what to do in terms of your engineering process. And I do believe that Agile is actually great for software as a service, though. And then actually, like for many website projects, it's a good fit. Okay. Okay, let's move on. Oh, actually, we could have a break. Anyone want a break? Like a 5 minute break? If not, I will just go ahead. I'll just count 5, 4, 3, 2, 1. Okay. Let's just go ahead for the next video.
If I was going to give a bio sketch of what's happened in software engineering, it's really, over the last 60 years, it's a migration from plan and document towards Agile. And that doesn't mean that Agile has completely displaced plan and document, but we've seen a lot more scenarios where a way of doing things differently from what was originally conceived as software engineering has turned out to make some sense. And to illustrate this, let's talk about software's greatest hits. We've got, let's see if this is a little kinder to me now. If I actually, yay, the right thing.
Aircraft manufacturers have tried to fix that problem by designing the pilot out of the cockpit. This is the first fully automated plane, flown by a computer.
That's Forrest, by the way.
Oh no.
Okay, so in case you don't speak French, oh la la is French for osh. Hold on, let's, there's more.
Décollage.
Décollage means takeoff. Okay. Okay, so I'm sure somebody there also said ooh la la, and we just didn't hear it. Those were both software bugs. The hardware was working as designed, but something in the integration of different software subsystems wasn't thoroughly enough tested. And if you'd like to read about a lot more software bugs just like that, I encourage you to follow this link, and the slides are up right after lecture, but history's worst software bugs. This is like 2 out of a collection of 20. So why does this happen? Why is it that, when they build buildings, the buildings don't just arbitrarily fall down? When they build bridges, the bridges don't just arbitrarily collapse. So why can't we build software the same way that we build things like infrastructure? Now, leaving aside the fact that in real life, 90% of infrastructure projects actually are late or over budget. The light rail they're trying to build out to the ballpark, in case you don't believe me. But at any rate, they don't fail so spectacularly for the most part. And what are we doing wrong in software in some sense that we can't do that? So the original idea was, let's do software projects the same way we do infrastructure projects. And a family of approaches that we're loosely going to call plan and document, which is essentially you do a lot of planning up front, and you only go from the planning stages to the building stages when everybody is in agreement on what the next step is supposed to be. So there's a project manager who makes a plan. You have very detailed design documents. You know where you're supposed to be at any given point in time, so you can have a way of measuring your progress. And if any changes happen, those changes have to be retroactively reflected all the way back to the design docs or whatever. You've probably heard of this. It's called the Waterfall lifecycle or the Waterfall development model. And basically, the software project, like a real project, goes through 5 phases. In the first, you figure out what it is you are supposed to build. What functions does it need to perform and under what circumstances? What is the architectural design? In other words, what is the collection of large subsystems that are going to be put together to make this piece of software work? Once you've decided that, you can actually get on with the task of creating it, writing the actual code for the subsystems, linking the subsystems together. Somebody's got to figure out that you actually, wow, that was interesting. That's fun. There's supposed to be a thing there that says verification, that it doesn't have bugs. I like that, don't you? Verification, or what some might call testing after the fact. You built it, but did you build it right? Does it actually function the way that you thought it would? And finally, you put the thing into operations, and you do whatever is required to maintain it. Each phase has to be complete before you start the next one, because the philosophy is the earlier you find a mistake, whether it's in your documentation and your design requirements, the cheaper it is to fix. Right? It's easier to add an inch to the car before it comes off the assembly line. It's easier to make a critical change to the software before all of the tests and code have been written and deployed. That was the idea. So, is that a successful model for software development? You might think this is the place where I'm like hating on the waterfall model, but no. In fact, another article that I encourage you to read called "They Write the Right Stuff" describes how the team that, until the space shuttle was retired a few years ago, the team in charge of the space shuttle software, which is immensely complicated. The space shuttle basically flies on autopilot the whole time. So the software system is a bear, and yet, in a 420,000 line of code base, each of the last 3 versions has had 1 or 0 bugs. That's amazing. Right? Commercial software of that size would have hundreds of bugs if you're just looking at the statistics. It's a team of about 260 developers. There's only it's one of only 4 software shops in the entire world that has earned the most mature, most sophisticated, highest maturity rating from the Software Engineering Institute. Maturity is a way of measuring the extent to which your organization can measure and feed the results of its process back to improve the process. So can you predict how many bugs you're going to have? And how good are you at doing that? How good are you at predicting when you've done enough testing that the next bug will take many years to find? And they did this by rigorously adhering to that model. There's an anecdote about how at one point they had to change about 6,000 lines of code, which is less than 2% of the code base, to add support for GPS satellite navigation. And that turned into 2,500 pages of documentation that could be written before anybody could change or write a new line of code. So this is taking the waterfall process to an extreme. The problem is it wasn't as successful an approach for software development for other kinds of software. In particular, what is a property of things like space shuttle software that might not apply to, I don't know, a new ride-sharing app, financial reporting for a startup, things like that? What are properties of the kind of software like the space shuttle team that might actually think this is a good way to do it? It can be permanent, and it's or at least very, very rarely updated, right? So if the thing that you're writing is like, and it's like a bridge, right? When you build a bridge, you don't finish building it and then say, you know, we really should have had 3 lanes in that direction. Can you modify it to add a lane? Although they did that to the San Mateo Bridge a few years ago. And by the way, it costs more to add a lane to the San Mateo Bridge than it costs to build the entire bridge in the first place in adjusted dollars. So yeah, if you're not going to change it very frequently, then having a very rigid specification and a very heavyweight process anytime a change has to be made makes some sense. It allows you to do a much more thorough job of checking, did the specification really cover all the circumstances? Does the implementation really do what the specification says? But if you're building something that may evolve, and this is something you should get used to hearing from your soon-to-be customers in this class, it's just what we asked for, but not what we want. The user and you will come to an agreement on what you're building, and once the user tries it out, they'll say, that's exactly what we asked for, but now that we actually try it out, it'd be better if you had done it this way. Could you just change it and do it that way? And this is the fundamental insight of Agile, in my opinion. The strength of software is that you could say yes. You can change software. It's not like changing a bridge. However, the waterfall process is not one that is really good about gracefully handling change, as we've seen. So that's one of the characteristics that, if you're building something that's customer-facing, and your customers might want changes sort of on an ongoing basis, you need a process that does a better job of handling that. So what happens if you don't do that? Again, another great article, the Software Wall of Shame, looking at a collection, 3 different big surveys of big software projects, looking at projects that were later over budget, so over 50% in the first study, and 20% in another study. Projects that were on time and on budget, only 16% in the main study. And projects that were never even finished. They went so off into the weeds that they were just abandoned, and all the money sunk into them until that point just had to be left on the table. And by the way, when I say on time or over time or over budget, it was about a factor of 3 on both of those things. So not a great track record when you try to take the kind of project where customers might change their minds, but you try to apply a development methodology that is a poor fit for that. So what could you do instead? Well, one thing you could do is, and Fred Brooks is given credit for this quote, throw it away. You build one whole system according to that methodology. With the benefit of 20/20 hindsight, you know what you should have built, so now you build it again. Not a super economical way to do things, but it was kind of an early lesson in software engineering of like, yeah, you might think you can specify the whole thing, but if you're, in some sense, coding to a moving target, you're going to have to do something to reconcile that reality with it's not part of your plan. So, yeah, after you build the first one, you know what you should have done, but is the best thing to do really to just discard the effort and start all over again from brand new code? I mean, can't we do better than that? So an improvement on the waterfall was, okay, well, let's try this instead. If you think of time as going sort of clockwise around the spiral, early on in the process, we'll build a prototype. And the prototype will only implement a subset of what the product is supposed to do, but it gives the customer a chance to get some feedback that might influence building the next prototype, and the next one, and the next one, and eventually you've thrown some prototypes away, but a prototype is a lot less work than the full system. So you learn a little from each one you throw away. You eventually get to the actual system you wanted to build. Certainly an improvement, because each time you're getting a new prototype, it's based on feedback about what you could have done better in the previous one. But those prototypes may still be pretty far apart in time. What you're really doing is mini waterfalls, each of which ends in a prototype that lets you learn something from having tried to build it. There's a variant of this called the rational unified process, where you're building prototypes, but you can sort of overlap the production of one prototype with the beginning of the design phase for the next one. But still, you're talking about doing things that are far apart in time. And one way to think about the motivation for things like Agile is, if I build a prototype now, and I'm going to wait X number of months for the customer to be able to give me feedback on that prototype, that amount of work in between is the risk I'm taking, assuming that I'm going to do the right thing. So the longer I go without feedback or without learning from what I've built, the more I increase the risk that the thing I'm building will not make sense, that I will have had to waste some effort.
All right, so that's that video. Basically, we've covered the traditional way of software development, which is waterfall, and then the pivotal approach or iterative approach, which basically have, like, for each iteration, it's a small waterfall process. But I do want to bring up another thing here. So here we can see so the main reason or the main problem where to address with these different software development approaches is to, again, accommodate future changes, right? And the reason we should assume there will be future changes or expect future changes is because one that's already mentioned, like the customer or the product owner don't actually know what they want. You may think it's like ridiculous, but it's actually very true. Most of the time, people actually don't know what they want until they actually touch it, for a product, like until they touch the product, feel the product, and then they realize, oh, actually, it's missing a feature, or it's something doesn't do quite right, and so that's one of the biggest reason that we should expect changes. And if we, draw it into a picture, so all the way to this end, let's say that's the product, the actual product that will satisfy the customer or the product owner. And then here is what we built, right? There are actually multiple gaps from here to there. So first, we already mentioned the person itself him or herself may not know what they actually want. And then from here, even if they know it, they need to convey that idea. Like, for example, I want a website that can order some food for me. That's an idea, but in order to describe, like, so how exactly I'm going to use the website, there's a gap between the idea that I have conceived in my mind and the way I describe it and then convey it to the actual developer. Right, and then from here, there's another gap, like from what the developer hears and then to what he or she actually understood. Every people have their own interpretations on certain things. Like, even, for example, if I say apple, some people may think, oh, apple is sweet. But for me, I actually think apple is kind of sour, and I don't really like apple. And another example would be like colors. So there are people who are colorblind. Like, if you say red or blue, they may not conceive it the same way as we do. So there's another gap here. So between like what the customer really wants and the product that will satisfy the customer, to hear what the programmer or the developer team actually develops, there's a huge gap, and then there are multiple steps between the ideas, the communications, and then the approach that we're going to talk about is basically based on the assumption that there are gaps, and then because of these gaps, there will always be changes. And then actually there's another reason for changes, because things keeps changing over time, right? Something that's relevant today may not be relevant any longer 2 years down the line, 5 years down the line, right? Think about that. 10 years ago, we don't even have smartphones, and today, smartphone is so popular in the economy. So, and because of cell phone, like website has changed a lot. Where back then, I think websites are mostly static HTML pages, and then there are like dynamic generated websites, and today we have single page applications with something like React, Vue, Angular, these frameworks that do all this fancy stuff in the front end. And then also to accommodate a mobile platform, their responsive designs, and Google was pushing that AMP web pages and all that things. So just in a short period of time, like 5 years, 10 years, things got changed a lot. And because of that, we should also expect changes in whatever software we develop. But revisit the previous points again. Even though we should expect the changes, sometimes we actually the changes are not really relevant. One reason, maybe you won't be involved in the project anymore. And the other thing I commonly see is, which also happened to some of the projects I worked on before. For example, I built a site with Ruby on Rails, and then the person after me know nothing about Ruby on Rails. And then probably the person is a big fan of, let's say, PHP. And then there's a request for change comes, and then the person after me might also, like the professor mentioned, throw it away because he has no idea about Ruby on Rails, and then build from scratch again. Sometimes that happens. The other example was the other work I did for server automation. We used Chef, which is a configuration management tool, whatever you call it, that manages the server configurations and take care of provision and deployment of the servers. Again, the person after me know nothing about chef, or even Linux or server or configuration, anything like that. Had no idea, and then in the end, the system will just be thrown away and then rebuilt from whatever tool of choice for the next person. So there are still cases where, even though there are changes expected, but you don't need to worry about the future changes that much. Again, depending on our situation, it's also a culture thing. Depending on the culture of your company or ministry, this can change greatly. So again, even though we talk about these good practices, try to see how it can fit into your situation. Okay. Oh yeah, the other thing I do want to mention. So in the next video, the professor is going to start talking about Agile. But before we actually get into that, since we already touched that, the reason for some improvement to the procedure is we need to better deal with the changes. But the changes need to be based on the feedbacks from the clients, the customers, the stakeholders, or product owner, right? And again, that's something usually we cannot, it's not something for us to decide. Again, going to some examples, let's say if you are working on some outsourcing projects, right? And I've actually worked on some of those. There's a good chance, especially for low budget projects, the customer or the clients will want a certain estimate, right? So basically, later you will learn about Agile a bit more. Basically, what we'll say about Agile is, let's be flexible, right? So given the timeline and the tasks or the features we want to deliver, let's see how we can fit that into the timeline, and then iterate like once a week, and to monitor progress and give updates. And if something goes wrong, we make the decision again, like if the schedule is behind, is there a certain feature we can get rid of in order to fit timeline, or can we extend the timeline a bit more so that we can finish all these features, right? So that's one of the basic principles of Agile. But then when you work on outsourcing projects, chances are you don't have the chance to do something like that. The customer wants a clear estimate in terms of time and cost, right? Most likely a client will talk to it. Let's say, imagine you are a client and you want to outsource some of your project, right? And imagine it's a low budget project, something like 5K, 10K, 20K, then most likely we'll approach a few outsourcing shops, ask them to give you a proposal or quote, like their estimates in terms of the timeline, how much it will cost. And then if one of them say, hey, we actually cannot give you a clear timeline because we are going with the Agile approach, we will just go according to what we see, and then we will keep give you updates though, so you will know the progress every week. Sometimes it's not feasible, right? If that makes sense. And then again, to do Agile or to actually solve, to improve how we tackle the changes, we actually need constant feedbacks from the stakeholders, product manager, customer, clients, you name it. So, but then there are chances where there will be customers, clients, stakeholders who are too busy to join like Scrum meetings, or to put it in plain words, to join like daily meeting daily stand-up meeting or even weekly meeting. There are people too busy for that. Then if they are not involved in the meetings or the planning and the iterations, that means you don't get feedback. But all the changes actually depends on the feedbacks. So sometimes that's also not feasible. And that's actually not something developer team can do, right? Although as a developer, you can voice the concerns like, hey, we need the product manager to join the meeting to, to go over the progress we have so far, and then to have a plan. And sometimes maybe you want your boss to join the meetings, but they are too busy. So to adopt something like Agile, I would say most of the time it's something more than about adopting it in a dev team. Whether it's more about a culture thing in a ministry or in a company. And again, that's something probably you cannot decide, but as a developer, we can always have our voice and give our recommendations. So that's also something you should take into consideration when you plan a project and then make decisions on how you are going to approach certain project. All right, let's get into the next video.
As we've seen, the plan and document processes rely heavily on heavyweight documentation and a project manager who can keep track of it. And the question is, can we do something that is more than just hacking? So not just saying, oh, we're going to throw all that away. Like the initial slide, you go start coding, I'll find out what the customer wants. So can we do something better than that, where there is still some discipline, some structure, but we have some process in place that is more graceful at dealing with change, which we know will come. And in 2001, the Agile Manifesto was sort of like Martin Luther nailing his 95 theses and kicking off the Reformation. A group of software engineers who said, we're uncovering better ways of developing software by doing it and helping others do it. And we've come to value individuals and interactions over processes and tools. So not that processes and tools are unimportant, but that they shouldn't be the truth. The truth is how the team and the team with the customer interact with each other. Working software over comprehensive documentation. It's more important to have a prototype or a partial implementation that can be commented on and learned from now than to wait until you have a version that absolutely satisfies every detail of what the design docs say. Customer collaboration over negotiating a contract. Not everything the customer wants will be possible, and hey, software is hard. Every bit, it's not like when you build a bridge, you're using a brand new design that's never been used for any bridge. That's pretty rare. But if you're building software, you probably are doing something in there that is new. Because if you're not, you should be using some other off-the-shelf software to solve your problem. So sometimes you'll be wrong about how hard it is to build something, and it's not productive for the result of that to be the customer saying, well, our contract was you would do those things. That's the time when the software team and the customer come together and say, okay, we were trying to do a thing that was new, and it turned out to be harder than we expected. Where do we go from here? And finally, responding to change over following a plan. It's not that you should never have a plan. Plans are good. But a plan is there to give you a guideline and to know when you've deviated from the plan, to give you a signal where you say, well, OK, why did we deviate from the plan? What did we not foresee? So it's not that the things on the right have no value. It's just that the things on the left should have relatively more value. So how do you translate this into a way of building software? Well, first of all, we assume change is a fact of life. Change is what software does well. So we're going to have a very different view of the world. The prototype is always there. In fact, there's no hard distinction between the prototype and the real system because the prototype gets better and better. And the customer is part of that process. Iterations can be quite short. In the real world, 1 week is typical. In our class, it's 2 weeks because of the constraints of scheduling. But basically, every iteration means all the elements of the life cycle happen. So in Waterfall, we talk about gather the requirements, figure out the architectural changes, do the implementation, do the testing. We're going to do that in every single iteration. It's just that because the iteration only covers a small amount of functionality, right, just enough to get to the next higher level of a better prototype, Each of those phases will take much less time. We're going to use test-driven development to reduce mistakes, and I'll explain the rationale for that momentarily. In terms of how do we interact with the customer, user stories are going to help us find a common meeting point where we can agree on what the customer wants. And we're going to use a simple scheme called velocity to get better at estimating how long we think it'll take to do stuff, so that working with the customer, we can prioritize when there's more things to be done than there is time to do them. You'll start each round, each iteration, by talking to the customer. You'll come to some sort of agreement and come up with lo-fi mock-ups of what the customer believes is going to happen during that iteration, what's going to be implemented or improved or fixed. Maybe there was something that you did the previous iteration that didn't quite match their expectations, so you need to go back and tune it. You'll turn those agreements into user stories and scenarios. If you've taken 160 or a comparable class in user interfaces, you know that a user story is essentially a sequence of steps from the point of view of the user, that when the user does this, then they should expect this to happen. Or when the user does this, then the internal state of the app should change in such a way that something is the case. And in fact, we're going to take those user stories and use a tool called Cucumber to basically turn almost English language stories into tests, actually runnable tests, that also, by the way, serve as documentation. Because it is much easier to read a user story written in plain English that says, when the customer does this, here's what should happen, than it is to try to decipher that same thing by tracing through the code. So documentation and tests actually are almost two sides of the same coin in many ways. When you actually come to write the code, we will write the tests first. If you've done test-first development, you probably remember it was really weird the first time you did it. If you've been doing test-first development for a while, you may remember that it's still pretty weird even after you've done it for a while. However, the number of stupid mistakes that it catches and the way that it makes you think about your code makes it well worth the effort. And one of my kind of big messages to all of you is we're going to be asking you to code and think about code in ways that you might not be accustomed to. Have a little faith in the process and try it. It's going to feel weird the first time you do it, kind of like putting your head underwater or something. But trust us, you will not drown. It gets a lot better. So hang in there with us. Measure velocity. A really useful thing is for you to be able to estimate as a team how much you can actually get done between now and the next time you meet with that customer, or give the customer the opportunity to give feedback on what you've done. So our hope is that using the techniques we're going to teach you, over time you will get better at doing that. So that if the customer says, I really want X, Y, and Z, your team can come back and say, you know what, in the time we have, we can do 2 out of those 3 things. So you, the customer, need to prioritize which is the most important for your business value, and we'll do those first. And finally, as I said, you're going to be frequently deploying. As you probably know, sites like Amazon or Facebook are deploying new code to production many times per day. I don't really think most of your teams will be deploying many times per day, but you'll be deploying frequently enough that as soon as you've got new functionality that you want the customer's feedback on, it's up and available for them. So you'll do that 4 times, because that's how much time we have in a semester. And along the way, we're going to talk about legacy code, design patterns, the interaction between those two, and how legacy and agile are really 2 sides of the same coin. And that's kind of going to be your life cycle. You're going to get really good at doing all of those things. So if you hate the part where you gather requirements from the user, sorry, you're going to do it 4 times, and you get better at it. Okay? So I like to think of just like a shark needs to keep swimming to live, software needs to always sort of be stewarded, maintained, monitored in order to remain alive and remain viable. So think of this as not you deliver a piece of software. What you're doing is you're participating in a process. And that process is ongoing for the life of that piece of software. People may rotate on and off of that team, but the process of how the software is developed is what persists. In particular, the variant of Agile that we mostly use in this class is Extreme Programming, or XP. I kind of think that name is weird because it makes me think of like programming with a helmet on or something. But Kent Beck, who I believe still works at Facebook now, is sort of given credit for putting forth the following rationale. It's like, look, if we're going to do this Agile thing, if the reason we're doing iterations is we want a short iteration so that we can get feedback more frequently, then let's make them really short. Like a week is much better than months or even a year. If it's good to have simple code, then do the simplest thing that could possibly work. Don't try to plan today for all the things that the customer might do with this feature in some possible future. Do what the customer needs now and develop ways to deal with change so that if the customer later needs to do more with that feature, you'll be able to grow into it. If testing is good, and surely we all agree that it is, then you should be testing all the time. In fact, you should be writing the tests almost alongside the code. Right before you write like 5 lines of code, first write a test that captures what you believe that code is supposed to do. And for me, the big revelation of doing this is not that, yeah, it forces you to write more tests. It does that. But it makes you think about your code differently, because it makes you think about, from the outside, what would somebody coming into my code base expect that my code should do? If you have trouble circumscribing that in a test, your code's probably not cleanly factored. And this is one of the biggest revelations to me of really sticking to test-driven development. It makes you think about your code in a more disciplined and structured way. And finally, we're going to talk about code reviews, having your team or members of another team sort of give a third-party opinion on aspects of your design. That's widely considered a good thing. So if it is good, why shouldn't we do code reviews all the time? Let's program with a partner, and in such a way that the partner is always doing sort of an ongoing microcode review. And in fact, let's switch partners all the time so someone always gets to be the reviewer. That also spreads knowledge throughout the team. So all he's saying is, we're going to take these things that everybody agrees are good for building high-quality software, and we're just going to take them to their logical extreme, hence extreme programming. When this was all put forward in 2001, some people thought that it was kind of, this is a way to legitimize hacking, right? It's a way to say, oh, we don't need all these documentation, we're going to get rid of all that. And that's, I think, for a long time, the image that Agile software engineering had. It was the thing you do when you don't want to do anything, when you just want to start coding and not have to deal with meetings or documentation. But it is not that at all, right? It is the same life cycle. You still have to know the customer needs. You still have to verify that you built the right thing. But we're going to do those things on a much finer-grained, sliced a lot more thinly kind of scale. It has now become mainstream. So for the most part, most worldwide software companies are now using some form of Agile, especially in their distributed teams. And it's essentially, you sort of need a reason not to use it. If you're working on the kind of project where the customer is not available, or it's a critical system, or one that is rarely going to change, those are great reasons, as in the case of the Space Shuttle software design team, to use plan and document methods. But if those things aren't the case, if you have the customer, if they're willing to be part of the process, if change is likely in the future of the software project, Agile is probably a good fit.
All right, so that's that video. Basically, the professor briefly mentioned what is Agile and different components to Agile. And actually sort of follows the syllabus where, what each of these topics will cover. So before getting into the next video, I do want to talk about this reading material. So yeah, in order to access this reading material, you will need to sign up for this edX course, and you will have access to this one. This is basically Module 1, Section 1.3, and then there's this reading material. Some of those, the professor already showed it in the slides. What I want to put an emphasis is this sheet. So when you start a new project, or even just reviewing an existing project process, here are just a few questions you could ask yourselves, and based on the answers, it will help you to decide which practice is good for you, and some may not be a good fit. Right? Is specification required? For example, if you are working on a hobby project or something that's really of kind of a research in nature, where you actually don't know what you are looking for, but you are just exploring a certain thing, you may answer no for the first question. Then in that case, maybe Agile is not for you. And then I won't spend all the time going through these all these 10 questions, but when you get the time, it's highly recommended to go through that and think about what kind of situation you can imagine or is there any example you can connect to these questions and see how it affect, imagining you are going to be the project manager, how it is going to affect your decisions on the process. Okay, so that's a reading material I really want to recommend. You could actually also just pause the video here and then read through it and think about that. But for the time being, we need to move on to the next video.
Let's talk about software quality. What does it mean for something to be a quality item? What makes something of good quality versus not of good quality? Human readability. Okay, so in the case of software, human readability might be a thing that connotes quality. But more just quality in general. If I say this is a high quality item, what am I saying about the properties of that item? What makes it a high quality versus low quality item? Works well, right? I got the item because I'm trying to solve a problem. I want to use it for something. And if it does the thing that I need it to do, that makes it valuable. Business people call it fitness for use. And that means that there's a business value for both the customer and whoever's producing the item. If you're producing the software, the business value to you is people pay you to use it, or you somehow make money from it, let's say. And if you're the user, the product solves some problem that you have. And so it's reasonable to expect that quality assurance is the process by which you ensure that both sides of that relationship are getting maintained. What that means for software is, from the point of view of the customer, it solves whatever problem they have. From the point of view of the developers, it's relatively easy, well, easy in scare quotes, because software is just difficult. But the developer can debug it, can enhance it, essentially can respond to the customer's demands to make it even more valuable, right? So that's what software quality is, which means when you think about what does the software quality or software QA department do, or in a well-run modern software company, what should it do? What it used to be is you'd say, oh, we finished the code and now we've thrown it over the wall to QA. QA does the testing. That is not how modern software companies are run. Or if you're at a modern software company that is run that way, you should run away screaming. Because what the QA department's job is to actually make sure that the processes and tools in the company are optimized to support those goals. If you're a developer at Google, but there's this famous anecdote where, anybody ever read the book Code Complete? Code Complete? I'll put up the programmer's bookshelf of books that everybody should have to be inspired by. But for a long time, there was this very famous sort of anecdote that at Microsoft, the ratio of software testers to software developers was basically 1-to-1. That for every person writing code, there was a person sort of paired with them to do testing. And a few years ago, we asked Google about this, and they were like, oh, I don't know, there's maybe one software QA engineer for every like 10 or 20 software developers. And should we be horrified? No, because the software developers are doing their own testing. The software QA engineers are in charge of the tools, processes, measurements, basically making it possible to do testing better, right? So testing is a first-class thing at Google and at most companies that take software engineering seriously. So this is, I think, maybe a different view of software QA, certainly a different view than there was sort of 20 years ago. I'm not sure what view most of you have had about this, but as a developer, you are responsible for your own testing. There are processes and tools in place that will sort of give you a handle on how well you're doing it. What form of testing do you do? There's really two different things that we want to know when we're building software, and we call them verification and validation. Basically, it's did you build the thing right? Did you build the right thing? So did you build the thing right means we have an understanding of what the thing is supposed to do. Does the thing you built actually do that? Does it behave that way? Versus did you build the right thing means are you sure that, in fact, we are in agreement about what the thing is supposed to do? Have you really understood what the customer's requirements were? Have you agreed on the specific features that will make those requirements, fulfill the requirements for the customer? And both of these can be tested in two different ways. We can do testing, which means we stimulate the software in various ways. We observe what it does. We conclude whether it's doing the right thing. And we can also use formal methods, which we won't really cover much in this class, but essentially formal methods are an attempt to formally prove certain things about the behavior of a piece of software, proving that it can or can't do enter a certain set of states. But even if we're focused on testing, exhaustive testing is infeasible. And when we talk about test coverage in a few weeks, it'll start to become clear why 100% testing, even if it were feasible, wouldn't actually be a guarantee that there were no bugs. So we do the best we can, and essentially we divide and conquer. We have different kinds of tests that are used in different phases of software development and that are testing different kinds of things. Some of these you may have had access or exposure to in prior programming courses. Coverage, we're going to talk about it in great detail in a few weeks, but essentially it is a way of asking how much of the functionality of my software is being exercised by all of the tests that I have against it. And as we're going to see, that is actually remarkably slippery to pin down because it depends very heavily on how you define the behaviors. But very roughly, here's the kinds of testing that we're going to use. Unit testing, probably a lot of you have done this at some level. This is where you're basically calling a single method, function, procedure, call it what you want, and you're verifying that under various inputs it does what was expected. It doesn't throw an exception. You get the right answer back. Above that is module or functional test, where you have some behavior that you want to test that relies on multiple different units. So it could be that it calls multiple different functions. It might call functions in different classes, but it requires sort of different pieces of the code base to work together to do something. And what you're checking is whether the behavior as a whole does the right thing. At a level above that is an integration test. You've got sort of major subsystems within your application, and there's assumptions about how those subsystems communicate. There are tests that would exercise whether the units are making the right assumptions, whether when they have to cooperate on a task, they're doing so in a correct manner. And finally, above that, there's whole system tests, also called acceptance tests. These have a couple of different purposes. One of them is to test the whole thing. So this is kind of the moral equivalent of you've just coded a new feature in a web-facing app. You actually log in as a test user, and you manually step through the things it's supposed to do. Because you're also testing, in that case, does the feature behave the way the customer said? Right? The way that we're going to do our feature planning is essentially show the customer pretend lo-fi mock-ups of the feature, and once we get to agreement on that, that actually becomes the basis for writing an automated test that does what the customer would do if they were stepping through the mock-up. So we're going to be using all 4 levels of these with a couple of different testing tools. I'm going to go out on a limb and say you're going to learn to love testing. I hope that you'll learn to love it and be happy, but you'll learn to love it, whichever way.
Okay, so that will be our last video for today's lecture. I hope we could actually cover more videos, but we don't get the time to do so. Regardless, we will continue Module 1 on Thursday. Meanwhile, let me talk about the homework. So technically, you can already start working on your homework for week 1. So if you log into Populi, you would see week 1A and week 1B. Week 1B is for Thursday's lecture. So this is today's lecture. The homework for this week is basically write a summary, and if you have any thoughts, so you could also write about your reflections, your thoughts on this stuff that's covered in chapter 1 from the textbook. So again, the way you get the textbook is here. In the Populi, go to Syllabus, and under the links, you can find textbook PDF download. Open that link, you'll find the home page for the book. Look for this link, which leads you to the free PDF download, and you click it, download the book. Alright, I did mention that we will have a basic option, which is basically write a summary, and a bonus option, which is coding practices. But for week 1, where we're just going through the introductions, we won't have the bonus option. So basically for week 1, everybody will have to go with this homework. And there will be additional optional framework. Optional means it won't be scored. it won't be considered into your grades, anything, but it is just a recommended stuff for you to do after the lectures, so that you can be prepared before the next lecture. So that will be announced on Thursday. But basically for this week 1, the homework is to write a summary. So if you got time to spare, you can already start reading the textbook. And the homework is to write a summary and optionally write some of your reflections for chapter 1. And then regarding the due date, I'm actually not that strict on due date. So before the final exam and final project presentation, as long as you submit the homeworks anytime before that, it's totally fine for me. But still, the recommended way for you to do the homework is to do it at the end of each week, because some of the homeworks connects to the next module. For example, later we will get into the module to learn the Ruby programming language. If you don't get enough practice to learn Ruby and get yourself comfortable with Ruby, then the next module after that would be Rails, and Rails is actually built on top of Ruby, so you will most likely get trouble when you get into the next module. So still, it's really recommended for you to do all these homeworks on time, meaning during the weekends, basically, after the lecture. So like for this week's homework, the recommended way is to do it this weekend, but feel free to submit it anytime. I don't really care about the due date in terms of the score and your grade. Okay, hopefully that's clear. Alright, so that's about the homework. With that, we will conclude today's lecture, and on Thursday we will continue with our Module 1 videos, and there are still some of the topics we haven't covered yet, so we will talk about that 2 days later. Alright, if you got any question, feel free to leave a message in the chat or email me. Feel free to do so. Okay, so with that we will end. See you